We want to try to find all solutions to this problem. Um, First thing I notice here is we have a sine squared and we have a cosine. And so because they're not both cosines, this is not going to be factorable. So I have to get rid of the sine squared. So we use the Pythagorean identity. Pythagorean identity says that the sine squared of 5x plus the cosine squared of 5x has to equal 1. So then the sine squared has to equal 1 minus the cosine squared. So we're just going to substitute out this guy right there. 2 is on the outside. So rewriting it, I get 1 equals 2 parentheses 1 minus cosine squared of 5x, close parentheses, minus cosine of 5x. Okay, so now I just have cosine, so this is doable. Distribute the 2 through here, so 1 equals 2 minus 2 cosine squared 5x minus cosine of 5x. And then I think I'm going to take everything over to the left side. So so this one, I always like my squared term to be positive. So I'm going to add that over. So that's going to give me 2 cosine squared of 5x. Add this one over plus cosine of 5x. And then subtract that 2 over. So 1 minus 2 would be minus 1 equals 0. All right, so let's see, I moved this one here, I moved that one there, I moved that one there. Okay, counted for all my terms. That looks good. So this is a lot like having, for example, 2x squared plus x minus 1 equals 0. Does this factor? Let's see. It would have to be 2x times x, 1 times 1. And then if I put the minus here and the plus here, that's going to give me 2x squared plus 2x minus 1x minus 1. And there's my middle term of plus x. Yep, it does factor. So over here, this would factor as 2 cosine of 5x minus 1. So that's this factor times cosine of 5x plus 1. That's this factor equals 0. And then we break it into pieces. So this one right here says, let's switch colors, twice the cosine of 5x minus 1 equals 0. Subtract the 1, or sorry, add the 1 over, divide by 2. Cosine of 5x is equal to 1/2. Okay, so ignoring the 5x for a minute, unit circle, if cosine x is 1/2, that leads to this point up here or this point down there. And that I recognize as an angle of pi over 3. So one solution here would be 5x equals pi over 3. And you could double check with the arc cosine of 1/2 if you're not familiar with that. So that's one of the basic solutions. Other basic solution would be, let's see, the first box, solutions from 0 to 2 pi. Okay. So to get the other one down here, we want the positive version of that. So this right here would be 2 pi minus what the arc cosine says. 2 pi minus pi over 3. Let's see, what would that be? 2 pi minus pi over 3. 3 times 2 is 6. So 6 minus 1 is 5 pi over 3, should be the other one. And then divide by 5 over here, right? So I get, let's do green, x is equal to pi over 15 would be 1. And the other one would be this one, but divided by 5, right? So my other solution is 5x equals 5 pi over 3, divide by 5. 5 pi over 3 times 5. The 5's divide out, so my other one is pi over 3. So those are the first two solutions from this one. Let's see what this one tells us. This one solving would be cosine of 5x plus 1 equals 0. Subtract the 1. Cosine of 5x equals -1. All right, so before I get rid of the 5x, let's think about unit circle. When is x equal to -1? X equals -1 at this point only. And so that would be an angle of pi. So cosine of whatever equals -1 if whatever is pi. So 5x equals pi. So x equals pi over 5. All right, so the next one here should be pi over 5. And then multiples of the period. Now, because these have a 5x in them, the period is 2 pi over 5. So then I should add multiples of the period. So this right here is going to be 2 pi over 5. So from those first three solutions, I can get as many as I want. And k here, z means integer. I can't remember why they picked z. I think it's German. So that means k could be 0, 1, 2, 3, or -1, -2, -3. So side note at the top here, z means integers. So k is an element in the set 0, 1, 2, forever that way, and -1, -2, forever that way. So from either of these three solutions, I can add 2 pi over 5 over and over again, or subtract 2 pi over 5 over and over again, is basically what that says. Let's graph to see if that works. Okay, so I think I'm just going to type these in for now. Pi over 15, comma, pi over 3, comma, what's the other one, pi over 5. Double check. Yep. And then the period that generates more is 2 pi, oops, not poo, pi, there we go, over 5. All right, so before I hit submit, I want to graph to see if I did okay. So graph the original 2 sine squared minus cosine. Okay, so 2 sine raised to the second power of 5x plus or minus, I forgot now, minus cosine of 5x. And we want to know, when is that equal to 1? Y equals 1. Okay. Oh, interesting. Because the period is 2 pi over 5, there are actually more solutions less than 2 pi. Do they really want all of them or just the 3 basic ones? Huh. This question may not be worded right. We'll find out in a sec. All right, so I'm going to zoom in, I guess, a little bit. All right, so 2 pi is just after 6 over there. And so my first solution should be right here, pi over 15, yep. My second solution, there's the pi over 5, yep. And my third basic solution is the pi over 3. And then my claim is that this next one over here is 2 pi over 5 plus my first solution. So let's double check that. So the computer says it's 7 pi over 15. And if I go back to my notes to double check, if I take my first solution here, let's highlight the pi over 15, and I add 1 period, that should give me the 4th point down the road here. So according to the graph, I would call this one right here x1. This one in order would be x2. And this one would be here, it would be x3. And all other solutions are, you just add the period to get the one. So my claim is x4 is that basic, the first basic one, pi over 15 plus 1 period, 2 pi over 5. Common denominator would be 15, so times 3. So 6 pi plus pi is 7 pi over 15, and I believe that's what the computer said. Yep. All right, so, all right, what's this? I think this question might have not been worded right because we have a whole bunch of solutions here. Oops, I can't click on all of them. Oh, I can, less than 2 pi. We have, stop it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, maybe 15. It's that one. Yeah, that looks slightly less than 2 pi. All right, I don't think it wanted all 15. I think they just wanted the first 3 and then use the period to get the others. Let's submit and see what happens. Yep. Okay, so this wasn't worded quite right. It should say, I'll write to the person who wrote this and ask them if they can clean that up. The first answer box should be a list of solutions on the interval. Should say the first answer box should be a list of solutions within the first period of cosine of 5x. That's what they really meant. Okay, so that's worded slightly incorrectly, but we figured it out.